which has to do with capacity and constraint management. I've alluded to this a little bit before in earlier lectures, and we're going to talk about, do you have the capability to actually make the particular product? So especially when I would have been talking in chapter 4 about the fact, like in chapter 4, you just forecast, I need so many units. But we didn't actually deal with the fact, can you actually make that many units in the time period required? So we're going to talk about what capacity is, design capacity, effective capacity, utilization, bottlenecks, which is a big part of it. So capacity is very important. So when you look around the classroom, there will be a capacity to, in a physical classroom, to how many students can actually fit comfortably in the room. And with a virtual classroom, we're not limited by the physical constraints of the 4 walls and the desks and things along that line. But what happens with online courses compared to classroom, you can't put as many students normally into an online course because it is additional work for the people who are delivering the course. So typically a 40 person classroom that you have, a physical classroom, can now only be, usually 32 is considered to be the number. There's some organizations that are going to try it at 40 just because of budget constraints and things along that line. But then there's limitations as to what you can do. So things like threaded discussions are not possible because it's just too much. There's 40 students to mark, and there's 40 students to participate a couple times a week. I taught for an online university that did that, and they went from 25 to 30 to 35, and it was an incredible increase in the amount of work. It just became not worth it. So we've talked before, or at least in chapter number 4, were about the 3 time horizons: short, medium, and long term. We're going to look at things like fixed costs and throughput, which is the number of units that you can, as you can see, hold, receive, store, produce in a period of time. In economics, you would have talked about economies of scale, and this is a major part of capacity. So do you have a smaller roadside motel of 25 rooms or 50 or 75? So depending on where you're building, the size of the hotel is a big deal. Several years ago, I stayed at a brand new hotel in a very small town of about 3,000 people, and I think there was 20, maybe 30 rooms max. Small little dining room. Now, there is no way you are going to build a 30-room hotel on the Las Vegas Strip. We're talking thousands of rooms. Some of the hotels in Vegas are 5,000 rooms. So you need that for economies of scale. They're very large, they're very expensive, and they have very high fixed costs. So from econ, you would understand the relationship between high fixed costs and low operating costs and try to achieve that minimum point of the long run average cost curve. So in this case, the ideal size is a 50-room roadside motel. Above 50, it becomes more expensive. Below 50, it's also more expensive. So you have economies and diseconomies of scale. Design capacity. If you look around the classroom, there's be a certain number of desks or workstations. Now, if none of them are broken, if there's not a broken chair or broken table or anything along that line, then the room would be designed for, say, 40 students. But typically, there's something wrong. There's a chair that's broken or a power outlet that doesn't work. So those are typical of effective capacity. So effective capacity tends to be what the real operating situation is. Design capacity, if everything's perfect. And also things with capacity that are important is the fact that capacity is a speed rating. So when I say that, say, 40 students can fit in a classroom, I say 40 students per hour can fit in a classroom. Now, if you operate that classroom for 10 hours a day, your capacity for that room is actually 400 students per day. If you have 5 days a week of classes, you can actually fit 2,000 students in the classroom per week. So capacity, you have to have a time reference or a speed rating. Usually when I present this during a class, I say, how many students can you fit in this classroom? People look around and say 40. No, I can fit, if I can fit 2,000 people a week in there, and I've got 52 weeks, I can fit 10,000 people in this room. So I say the capacity of this room is 10,000 students. And they look at me and say, like, no, that's not possible. Yes, it is. And the maximum period of time, by the way, is a year. Now, we'll do some calculations of utilization. What percentage of the time is it actually used compared to obviously the design? Efficiency is the actual output simply divided by the effective capacity. Again, design capacity is when everything's perfect. Even a classroom, even if all the desks are fine, you can't necessarily run that classroom the 10 hours a day that I just mentioned. Why not? Because some point somebody needs to come in and clean it. So you might have the room available for 10 hours a day, but the cleaning person needs to come in for 20 minutes or whatever it takes, but that now blocks off you using that classroom for an hour. So you have the effective capacity would, let's say it's available for 10 hours a day, but you only are using it 9 because it needs to be cleaned for 1 hour a day. So the effective capacity would be 9 hours a day. So you take your actual and divide it by the effective capacity. We'll go through this a little bit more in a moment here. You can occasionally have demand exceeding capacity. What you would typically do are things that you learn in marketing: raise your prices, schedule longer lead times, etc. Or the long-term solution is, if you're absolutely sure demand is going to stay at a higher level than you can meet, you will try to increase your capacity, expand your plant, buy new equipment that's faster, hire more people, things along that line. And if you have slack or surplus where the capacity exceeds demand, perhaps you lower prices. Try to stimulate the market with advertising or promotions or things along that line. And very often you need to find, say, complementary products. So a company that makes skis might make tennis equipment. There was a company many years ago that made skis, which is in North America a winter sport in the, say, November to March or April period of time. So they were very busy making skis. By the end of the summer, they'd have nothing to do. So what they did with their plant was they started making tennis rackets, which would be a summer sport. So they tried to have like complementary products so that they go opposite to each other. So they make skis at one point in the time, and then when that ski demand wasn't there, they would make tennis rackets so they could keep their plant operating the whole year. And you can see in this particular case, here's an example of a company that makes snowmobiles. And of course, with seasonality, that goes up and down. They also make jet skis, and they are opposites each other. So as the snowmobile sales go up, the jet skis go down, and vice versa. So overall, you have a much flatter pattern, which is better. These real peaks and valleys, these extremes, are really difficult because you'd be hiring people, laying people off, needing equipment, having too much equipment, bringing in a lot of material, not bringing in a lot of material. So it's very difficult to actually implement. Where you bring in you have people employed all year. You need about the same amount of equipment. Yeah, the same amount of materials are arriving. So it's much easier when it's more stable or less variability. I'm not going to go through every single point, but some of the ways to match capacity to demand, as you see: adjust your staffing levels, up or down, adjusting equipment. So sometimes a company might not buy the equipment. They might lease it for a couple months. They don't need it for a longer period of time. Find efficiencies with improving the processes to increase your throughput. In other words, it's like productivity, where you would increase your productivity, be more efficient. Redesign your products so you can, again, increase throughput. So something as simple as years ago, Honda, with their Honda Civic, they used to put in 5 clips to hold the windshield in place while they were installing the windshield. Now, that took time and money for each one of the clips. They came up with a new process where they only had to put in, I can't remember if it was 2 or 3 clips. It saved them a lot of time. One other thing that Toyota, when they came out with a certain version of the Camry, in one version of the Camry, there's weather stripping on the frame for where your door is. At one point, they had these 3 pieces of, I think they were a sort of a rubberized plastic, but they'd have 3 weather strips on the door frame. That would reduce noise. That would also reduce so that you don't have dust and dirt coming into your vehicle. When they redesigned the Camry, what they did was they went from 3 strips to 1. Now, the 1 strip was actually wider than the 3 strips, but because you're not having to put on strip 1, strip 2, strip 3, that takes time and effort. They were actually able to reduce their costs because you just put on 1 strip. So think about this. If you had to draw on a piece of paper 3 lines with a simple pen, draw 1, 2, 3 lines, how long did that take? Or you had a felt marker that was wide enough and you just took 1 line. It's wider than the 3 individually, but it takes way less time. And point number 6, unfortunately, is negative, where you actually have to sometimes look at closing facilities. Bottlenecks. The bottleneck for a typical classroom is the door. You always have a bottleneck. You always have a constraint. So when I present this in a classroom, I say, where's the bottleneck? People say, well, the door is the bottleneck for leaving the room. I say, what if I remove the entire wall? Where's the bottleneck? Then that bottleneck will typically become the people who are at the end of the rows. So if you were sitting in a classroom and you wanted to get up and leave, you may, especially if you're in the middle of a row, you have to wait until the people beside you get out of your way. Same as like with a plane. It's been my experience that when I've traveled in North America, we have this system where everybody leaves through the same door. And I'm sure if most of you have been on a plane, you say, God, that's taking so long. When I've traveled in Europe, people load and unload from both the front of the plane and the back of the plane. I don't know why in North America we don't do that more, but that changes the bottleneck. You can load the plane a lot faster. You can unload the plane a lot faster, and you get the plane back up in the air as quickly as possible, because the plane is most expensive when it's sitting on the ground idle. It's not earning any revenue when it's sitting on the tarmac. When it's flying, it's earning revenue. But you always have a bottleneck, and the bottleneck can move. If you walk around a plant, it's very easy to see where the bottleneck is. Wherever the work in process is piled up, the step right after that is a bottleneck. So if you walk around a plant and you see a big pile of lumber or steel springs all piled up, whatever process is being applied right after that is where the bottleneck is. One of the tours I take my students on, there are metal sprigs. And the engineers literally on a daily basis wander around the plant and they can identify the bottlenecks by saying, oh, we are having an issue here. We need to get this person extra help or find a way to produce more, because the bottleneck is your constraint and will limit your output. So it's very important to have do bottleneck analysis. And once you solve the bottleneck at that point, it moves somewhere else. So you will always have a bottleneck. And we'll go through some of this in specific examples during the example portion of the lecture. Thank you.